Good morning, students. Children, today we will start our new chapter, whole numbers. So, children, as soon as you start your schooling at pre nursery level, you come to know mathematics with counting numbers 1, 2, 3, 4, 5, and so on. And these counting numbers are known as natural numbers. Now the question arises, what are whole numbers? Let me ask you one question. How many children are there in your class who are more than 20 years old? Your answer is 0. Yes. Is 0 a natural number? No. So when we include 0 in the set of natural numbers, we have the set of whole numbers. And we denote the set of natural numbers by capital N and that of whole numbers by capital W. Children, do you remember the concept of successor and predecessor? I told you this in your earlier classes. Let us recall. When we add 1 to a number, we get its successor. And when we subtract 1 from a number, we get its predecessor. Let us check it out with the help of an example. In this, write the successor and predecessor of 1000. Here you have to find out the successor of 1000. So to find out the successor of 1000, you will add 1 to 1000. So 1000 plus 1 will be 1001. And to find out the predecessor of 1000, you will subtract 1 from 1000. So 1000 minus 1 will be 999. Now let us see some of the properties of whole numbers. First is the closure property of addition of whole numbers, which states that if A and B are two whole numbers, then A plus B is also a whole number. Now to establish the closure property of addition in whole numbers, let us check out an example. When we add any two whole numbers, say 6 and 5, we get 11. Now tell me, is 11 a whole number? Yes, it is a whole number. So we can say that sum of any two whole numbers is a whole number. And this property is known as closure property for addition whole numbers. Next is the commutative property of addition of whole numbers. It states that if A and B are two whole numbers, then A plus B will be equal to B plus A. Now here we shall add any two whole numbers in two different ways by changing their order, and we will check whether the sum in both cases are same or not. Let us check it out with the help of an example. When we add 7 and 8, we get 15. Now when we change the order and add 8 and 7, then also we get 15. So we observe that the sum of two whole numbers remains the same when we change their order. That is, in addition of whole numbers, order in which we add does not alter the solution. And this property is known as commutative property of addition of whole numbers. Next comes the associative property of addition of whole numbers. It states that A, B, C are any three whole numbers, then A plus B added to C will be equal to A plus B plus C. Let us understand it with the help of an example. Here are three whole numbers 17, 12 and 13, which you have to add in different ways by changing their groups. So in first group you will add 12 and 13, which will be equal to 25, and 25 will be added to 17, which will be equal to 42. Now in second group you will first add 17 and 12, which will be equal to 29, and to 29 you will add 13, which will be equal to 42. In both the cases the answer will be same. So we observe here that the sum of any three whole numbers remains the same when we change their groups, and this property is known as associative property of addition of whole numbers. Next comes the additive identity. It states that if A is a whole number, then A plus 0 or 0 plus A will be equal to A. Let us check it out with the help of an example. Say 0 added to 5 or 5 added to 0 will be equal to 5. So here we see that sum of a whole number with another whole number 0 is equal to the non-zero whole number. In other words, you can say that adding 0 to a number gives the sum as the number itself. That is, 0 does not change the value of a number when it is added to it. So 0 is called the additive identity of whole numbers under addition. Hope it will be useful for you. Thank you.